Assalamualaikum. I'm hanafimajid. I'm going to present you the air pollution index forecasting model using AutoML. Okay, for the introduction, we knew that the previous method, which is the ARIMA model, has been widely used to predict or to produce the regression model, as mentioned by B. Donnelly in 2015, which is um, use the ARIMA model to forecast the particular matter 2.5 level in Fuzhou, China. But nowadays, the machine learning approaches has been predominant in the field of PM 2.5 to produce the prediction as studied by Yibin Chen in 2021. This is due to the capability of the machine learning, seems to be more productive and able to handle the volatile and unstable data. So this paper will examine how effectively air pollution index forecast model to predict or to produce the forecast value of the future value. So the more accurate that we have on the model, so the healthier people will be gotten. So that is among of the motivation um, of the necessitates the construction of a more accurate model um, in the context of PM 2.5 and PM 10 as studied by Li Zi in 2021. And the upgraded version of the machine learning is the AutoML, which is the model. The models are constructed automatically with the tuning of the hyperparameter. It will still require a human intervention on the hyperparameter tuning. So the data set will be encompassing the 12 months of from January 2019 to December 2019, and it will be observed 4,633 observations, which is cover 5 locations: Limbang, IRP Miri, Kapit, Samarahan, and Kuching. So the models will be compared with the statistical models such as INGAC and BINGAC and INAC. This is actually coming from the GAC, which is blend or inspired by the ARIMA approaches, but it is more focused on the error and variance. So the INGAC is the integer value of the GAC, and BINGAC is the nonlinear Bayesian method, and INAC is the integrated of the ARC, which also inspired by the ARIMA approaches. So that three models has been studied by Nura Ashikin in 2022. And then this experiment will be using H2O tools, AutoScaler and AutoVK. So this is the two of the workflow. The first one is the regular ML, and then the bottom one is the AutoML. So for the regular ML, we have 5 stages, which start with the data acquisition. So how the data is going to be retrieved. So in this study, we are retrieving the data from the portal Terbuka Malaysia, which is publicly available, so anyone can download it from there. Then the second stage is the pre-processing stages, which is including the how to handle the missing values. For example, fill up the missing values with the with the mean value from the data sets. Yep. And then the third stages is the feature engineering, which is including the hyperparameter tuning, for example, the value of the random states and so on. And then the fourth stage is the to evaluate the model. So we are using cross validation equal to 5. So means that the model will be validated five times. So the best results that we have, for example, for the first loops, will be carried forward to the next loops until five loops. So once we get the best model, so it will going to the fifth stage, which is the focus model. So the bottom one is the OTML. So we can see the center of the three stages has been bundled up together, which is the pre-processing, feature engineering, and model evaluation. So the intervention is needed on the early stage of the pipeline, which is we put everything in the hyperparameter yep of the pipeline, and then once we run the pipeline, and we it will produce the forecast model in the end. So the motivation of the use of machine learning, because it is able, or the capability of the machine learning, which is focused on finding effective assurance for the solutions, as mentioned by Vishwanathan in 2008. And also the existence of the OTML aims to lessen the necessity for data scientists, as mentioned or studied by Mark Andre Zoller in 2021. And then the among of the advantages of AutoML, because of the back end of pipeline, which is having a lot of algorithm that we have, including linear regression, and then the tree based, for example, random forest and decision tree. So we a lot of algorithms. So the pipeline will be choosing the best or optimal algorithm for uh, specific or particular data sets. So yep, because of the automated process, so the a few of the process that we have in regular ML will be avoided and bypassed in AutoML. So it seems to be more smooth in compare with the regular ML. It is also doesn't require much time. For example, when it is using the linear regressor method in the pipeline, there are three disadvantages of the AutoML. The first one is difficult to replicate the results. The second one is difficult to generalize the results. And the third one is difficult to evaluate the performance. This is actually going back to the no free lunch theorem, which is no single algorithm that fits for the solutions. So because we knew everything has been automated in the pipeline, so it is quite hard for us to replicate the results, because everything we already defined, already configured in the hyperparameter before the pipeline is run. So uh, we cannot replicate the results to the regular ML. So this is the methodology of this study. So the right side is the process, the workflow, the process of the methodology. So from the start, it is going to the first process, which is blending four tools, which is sklearn, auto sklearn, H2O, and auto and then it will be it will be assessed whether the training loops able to be run or not. If it is not able to run the training loops, the hyperparameter need to be retuned. And once the training loops able to be run, so it will be going to the comparative analysis process. So yeah, the performance metric that taken or considered in the study is MAE, RMSE, and the accuracy. So RMSE also including MSE, mean square error. So once the model has been going through the comparative analysis phase or process, that will be end the process. So the source data is using 24-hour format from Malaysia Open Portal data.gov.my. And then the proposed model incorporating a trend and seasonality into the model. The trend is the long-term increment or decrement on the in the graph, while the seasonality is the repetitive cycle in specific a period of time. The random forest is used to deal with the large data sets, and then the time taken to run the pipeline also is measured. So the performance metrics will be using correlation coefficients as the accuracy measurement. So yep, this is the results. The sklearn H2O and AutoWeka results will be compared in the table. And there are also significant difference in between highest and lowest value. This is due to the inputs data that having a fluctuation on the on the um, uh, on the data on the graph. And then the results produced by the AutoML seems to be having a higher accuracy in compare with the traditional statistical methods. This is the tables of the results for the 5 locations. The bold one is the best results um, in the context of MSE and the accuracy. Yeah, from the result, we can see that standard ML and AutoML outperform the traditional statistical model in terms of the MSE and accuracy for all 5 locations. And then the standard ML from the sklearn decision tree outperform the random forest, AutoWeka, H2O, and 3 traditional statistical model as evidenced by the MSE findings in the result table. However, the random forest from the sklearn outperform for the 2 locations of the ILP Miri and Kuching. In overall, the sklearn decision tree is the best forecasting model since it fits for the closest data. So majority of the accuracy from the AutoML and standard ML having 99%. And then the results that we have AutoML is quite competitive in terms of the MSE and accuracy value. In overall, AutoML continues to provide good accuracy, quite competitive accuracy value in compare with the standard ML. So the use of the AutoMLs also should be considering the cost and runtime, because the longer The longer training is run, so the cost will be more. In conclusion, the AutoML is the superior model than NBingak. NBingak is the best um, approaches previously, but results that we have from AutoML is the superior model than NBingak model. Both accuracy and RMSE value. It is showing that AutoML also to be an adaptable and intelligent forecasting model because a lot of the process has been automated, yeah, in the pipeline. So hyperparameter adjustment will making the AutoML outperform the standard INGAC and ARC family predictors. Yep.